Okay.
Off your roast, Joshua.
Stop. Stop being a bully.
Yeah.
Well, what's supposed to be?
A nice person.
Thanks, Miss Lucy.
What? Where?
Not in that direction right now. Okay, example. We need to look for our P. What's our P?
Positive 6.
Positive 6. So if P is positive 6, what's our what are the factors of positive 6? 3 and 2. 1 and 6. Yeah? 1, 2, 3, 6?
Mm-hmm.
1, 2, 3, 6. We could say positive or negative, right? So -1 times -6 is 6.
Why did they put 1, 2, 3, 6?
So P is our constant, and that's 6. And in our definition it says that we need to look for, so our rational roots come from the factors of our constant.
Oh.
So the factors of 6. Okay? And then we need our factors of our leading coefficient. What's our factors of our leading coefficient? 1. Una.
Uno, one might say. Yeah.
Okay, so now we need to find P over Q.
Just do each of the numbers if you
So 1 divided by 1 is 1. 2 divided by 1 is 2. 3 divided by 1 is 3. 6 divided by 1 is 6. Okay?
So what we do when we have multiple numbers called P and Q? No, we never will.
What do you mean?
Will we ever have multiple numbers in the Q as well as the P? So like how you have 1, 2, 3, 6, we'll
Here?
also have some down there.
Yes, because our leading coefficient isn't necessarily always going to be 1, right?
Do you just match them so whichever one is in the first?
Hey guys, Pancho has a good question. Can you say it louder for me?
So in that case, if Q has multiple numbers, would you just match them up, or would you have to do each one with each equation? So it'd be like 1 over 1.
Yeah. So good question. Pancho wanted to know if Q was going to be 1 or if it could be multiple numbers. So it depends on how high your leading coefficient is, but let's say our leading coefficient is 4. What are the factors of 4? 1, 2, and 4.
So then if you have those 3, which you have up there as 4, you have to do like 1 times everything up there, then 2 times everything up there. Oh.
So you would do, so let's say, so Panto's question, let's say that our leading coefficient was 4 and this is still 6. We would have 1, 2, 4 down here, right? We would need to divide this by this, this by this, this by this. And yeah, you'll get multiples of those, right, sometimes, or 2 over 4 is 1/2, but we already have 1/2, so we don't need it again. But yes, you can have multiple Q's, and yes, you need to divide your P's by your multiple Q's if you have them.
I'm still confused how we got the P.
P, okay, so in our problem here, we've got 6 as our constant.
Oh.
Our number that doesn't have a variable with it.
I was thinking the first one, and I was thinking A for the constant, like.
Yeah. So yeah, 6 was our constant. Okay, great questions, guys. Okay, so this gives us a list. Oh, you can't see that now. Okay, so this gives us a list that we can generate and we can see and we can look for zeros. So this is our list that we can use, +1, -1, +2, -2, and so on, that we can look for to see if they're factors of our original polynomial. So it narrows it down. So it doesn't necessarily take away everything, like not all of these are going to work. There's 8 of them, right? And how many should work?
2?
Is it to the degree?
So yeah, we have, okay.
So 1 or 3.
I don't know where the
Logan. We have a fourth degree polynomial. How many x-intercepts do we need to have?
At least one. Oh, x-intercepts. Sorry.
At least 3 or 1.
No, that's because those are the extremities. I'm an idiot.
4.
X-intercepts.
I'm going back to my original
Just
answer
read the
of
amount
4.
she has.
One word.
We have a fourth degree, we need 4 x-intercepts. It's our highest degree. Okay?
Okay.
Of these numbers, we have 8 numbers right here that we can try to see if they're factors of our original polynomial. How many of these numbers will work?
Half of them.
Half, 4 of them. So what this does is it gives us a list that we can look at and try to divide. Yeah,
What
question.
if we have a 0 that's not a rational number?
A 0 that's not a rational
We're
number.
doing rational numbers right now?
But could one of our zeros be irrational though, and
No.
not be on that list?
No.
As long as it's not on the
Yeah.
test.
Wait, couldn't it? I thought zeros could be rational.
Well, if you had like,
You're thinking imaginary.
I'm clearly like
if
making
one of your
some
factors, if one of your factors was x minus pi, how do you x-intercept?
I'll do that here too.
But I thought when we were doing irrational numbers, you said that 0 is not a possible irrational number.
This
That-
is a sketching thing.
Well, these are
Oh.
possible rational ones, but that helps us break it down to find that if there are irrational ones, we break down the rational first, and then we look for the irrational ones by like quadratic formula.
Oh, I get you. All right, cool. I'm picking up what you're throwing down.
Did everybody hear what Mr. Barron just said? What did he
Yeah.
confuse
I
you?
don't know what.
So we're looking for the rational
Takes
zeros.
a lot.
Well, what's the difference between a rational zero and an irrational zero?
So for instance, if you if you have a quadratic and it doesn't cross out, let's say it crossed at like 2.378926, whatever it crossed at, and it's not a rational number, like we can still find it using the quadratic formula, but it won't show up on our list because that list is just the rational ones.
Factors?
Yeah, they help us find the factors that are rational, and then once we break down all the rational numbers out of there, let's say we're left with a quadratic, and we just tried the quadratic formula, that helps us find if it wasn't factorable, then we'd use quadratic formula to find what they are. So it might be like square root of 2, which is an irrational number.
So this is the list of all rationals that we can find. There's 8 of them. It just makes the list smaller rather than having to try a bunch of random numbers or every number, right? So it makes it easier. And you told me earlier, Kevin, that we're going to use long division to find these. So if I've got +1, what would the factor be that we're looking at?
X minus 1.
X minus 1. So we can do, well, and I guess we don't really need to look at that, we can look at zeros. So we've got +1, we can put there, right? So I'll write it on the board. So what I want you guys to do, I'm going to erase this. Is using this list of numbers that we came up with right here. We're going to use, yeah, that's fine.
And this is to find the x-intercepts.
This is to find if these are x-intercepts or factors, yes.
Okay.
Because not all of them are going to be.
Yeah, only half.
Okay. So if we want to start with 1, we would start with 1, because we've got 1 here. And then we're going to, what's our polynomial? What am I writing up here? What's the polynomial we start with?
X to the 4.
So we need what here? 1, okay.
And another 1.
-1. Positive 6.
And 6. So what I want you guys to do in your groups is to test these numbers and see if we get factors, what factors we get from them.
All right.
So we're using long division, or not long division. I would suggest synthetic division to test these numbers. And you could have multiple people, like Kevin could do one number, Logan could do the other. Kind of divide and conquer and see what you get as your factors for this polynomial.
Is there supposed to be a remainder?
If it's a factor, is there a remainder?
No, but I'm pretty sure I got a remainder unless I did.
So if you get a remainder,
That's not a factor.
time out. Stop talking, please. If you get a remainder, what does that mean?
It's not a factor.
It's not a factor, so it's not going to be
Disregard. It's not gonna be.
an x-intercept, because that's what we're looking for, right? That's what we were missing in order to sketch the graph that we want to sketch.
So you have to do positive and negative.
Mm-hmm. So I would, I mean, yes, but
There's a remainder of negative was known to.
Yeah, I like those finesse. Okay, did I do this one right? I feel like it should end up crossing itself out, but it doesn't.
I'm almost two is yeah, negative. Okay, so yeah. You want to go with that?
Negative
I will
six.
go with- I will.
Yeah, I know I did something wrong, because I knew they wanted to give me the last one, just that.
But I will say there is a very high likelihood. Let me. I won't do three. Maybe I'll just say.
this is what we do. So define rational roots. We do our factors of our constant and our factors
Plus
of our
1 is a factor.
coefficients.
El
So that's
compadre.
just a list of
Now we have to find negative.
see whether or not it's
Oh, three's not a factor.
And then I give
So how do you know it's a factor? So this should be negative, right? So you've got one, and you've got negative plus.
Two is six. Yeah, we're all plus negative 7, negative 0.
Oh, sorry, plus.
-0.
Sorry, it's still gonna be, it's negative 7 plus 2.
You get to choose whatever number from our pod right here. Our pod. Yeah, so that's the list of
So we know that this
It is
is
right, don't worry.
a factor, so what, how do we write this as a factor?
Yeah, this is.
So then,
Now we actually have to do the whole thing.
I'll do next round. When we divide the quotient or
So yeah, what's this new quotient? So what is this? This is our 0, what's the factor?
Wait, that's
One
negative
is,
1.
times 4.
so 1 is the 0. So when we write factors, it's x plus or minus something. So you would say, so you would write this in parentheses and then you would write this times this. So those would be multiplied together. So we found one factor. So now, can we just factor this? Can we factor this without doing division or without quadratic or something like that? Or is it possible to factor it in?
I believe he was on opium.
So what we
And I'm
do
not
is-
just talking about this Carol.
Yeah, no, I don't know. Yeah. When you just do the-
Yeah, so we do it with this is the equation.
Is that okay?
Hold on, Pablo.
Yeah, what's up? You said my name.
I thought you had a question. Oh, okay.
No, we're talking about opium and cocaine. And Lewis Carroll.
And Lewis Carroll.
Okay, has anyone found a factor?
Yeah.
What'd you find?
One.
Oh, okay.
One? Do we want to use this one?
Yes.
Okay. Let's just add that. So we're going to test out 1.
Yep. Test out -1.
So let's put this back in our notes, just so we know the process that we're wanting to go through here. So Ponto said that they found 1 as a 0, so what's our factor?
There we go.
X plus 1.